Hi everybody, I'm here with Thursday's maths lesson. So today I've decided that we will do a Year 6 style math starter, and then the main task will involve us revising a Year 5 fractions objective. So let's get started. Now on screen you can see a division calculation that I completed. So you can see my working. So the calculation was 257 divided by 4. And I got the answer 64 remainder 1. Now if you've been joining in with me all week, then hopefully you'll remember how to convert the remainder in this question into a fraction and decimal. So if you can, pause the video and write down your answer please. Okay, so the R1 in this question means 1/4. Okay, represents 1/4 because we've got 1 left over out of 4, because in every whole there are 4 equal parts. The decimal equivalent for 1/4 is 0.25. So we use that information to write the correct answer of 64.25. Now don't worry if you're still finding this tricky. In lots of questions in tests particularly, you can just leave it as R1 or R2 or whatever the remainder is. But sometimes you do need to be able to convert to a decimal, particularly if it's a real life context question, because sometimes you won't be able to understand. If it was money, for example, if it said how much money will each, if this was £257 shared between 4 people, and in your answer box, if the question had asked you how much will each person get, and you put £64 remainder 1, then your answer would be incorrect, because obviously that's not how we write amounts in money. So in that scenario, you would need to be able to do the decimal part. Okay, but a lot of the time you can just put R1. Normally, test questions will say, please give your answer as a decimal. Okay, so that's good to know. Now, I thought I'd just mention this because sometimes you'll be faced with questions like these. So I'm wondering if you can convert this remainder into a fraction and decimal. Pause the video and just have a think and then press play, because I think you might find this one's a bit more tricky. Right. So, in this question, I can convert the remainder to a fraction. So I know that as a fraction, it would be 6/7. So it would be 44 and 6/7. But I don't know the decimal equivalent for 6/7. That's not one of my known facts. So I'm a bit confused. So there is another way that you can convert the remainder into a decimal. And this is definitely a Year 6 objective. So this is a Year 6 idea. So if you're a Year 5, then you'll be doing this again next year. But I'm just going to reveal my workings. I wonder if you've seen anything like this before. So you can see here, maybe if I put my square back just to cover, so it looks a little bit overwhelming. So you can see here, my calculation was going fine, but I got to the end. And I was just about to write my R6, but I decided I wanted to make it a decimal. So what you do is you place a decimal point. Okay, so you put 1 in the working section and 1 on the answer line. And then you just put lots of zeros. And you just carry on the calculation. So when I would ask myself how many groups of 7 can I make out of 34, I knew that I could make 4 groups, which would use 28, and I had 6 left over, so a remainder of 6. So instead of writing R6, I passed it over the decimal point and I put it in front of the 0. So then I said to myself, how many groups of 7 can I make out of 60? Well, I said 8 groups, remainder 4. So you can see how it just carried on this process. So you can write as many zeros as you want to, but often in a question, in a test, it would say, please give your answer to 2 decimal places. So that would mean that you would have stopped here, okay? Because sometimes you can go on for a very long time. But I just thought I'd mention that because sometimes you might not know the decimal equivalent, so it's good to have an alternative strategy. Now I'm just wondering if you could complete these 2 calculations. So one of them you should be able to convert the remainder using a known fact, and the other you might need to do this method where you put your decimal points and then put some zeros and carry on the calculation. So I'd like you to have a go, but don't worry if you get stuck, because like I say, if you're year 5 particularly, we'll be doing more of this, and also if you're year 6, you'll definitely be doing more of it in year 7. So have a go. Right, I'm just going to reveal my workings. So I got, for the first one, I got 39 remainder 2. I turn the remainder 2 into 2 quarters because it's 2 out of 4. And I know that 2 quarters is 0.5 as a decimal. So now I'm looking at my answer and I'm unsure as to why I've written 39.25. I should have written 39.5. So that shows that I should have checked my workings. Oh dear. At least I've spotted it now. On the other question, okay, let me reveal this one. Let's move this up. So on the other question, I got remainder 3, which became 3/7. I was not sure of the decimal equivalent for 3/7. It's not a known fact. So I placed my decimal point and I carried the remainder on, and I decided to stop here because I didn't want to use any more of my time, but I could have carried on. Okay, let me know how you got on with that, because even if you've got to this point, the remainder 3 part, that's still good. Okay, right, we'll have another go at that tomorrow. Now I'm wondering if you can answer this question. The playground is separated into different zones: ball game zone and a quiet zone. These zones are not equal parts of the whole. So as you can see, the football area is larger than the quiet area. I guess they'd need more space for football, possibly. Can you answer this? What fraction of the playground is the ball game zone? So what fraction of the size? What fraction of the whole is this football zone? And what fraction of the playground is the quiet zone? Pause the video and see if you can do that. Right, I'm just going to put some workings on screen. So, I'm not sure if you remember, when we've been talking about fractions, we've always said that you can only express something as a fraction if all of the parts are equal. Okay? So when I looked at the previous picture, it looked confusing because the parts are not equal. So I drew some little lines in, and this helped me to visualise. So I can see that the football zone takes up 3 parts out of the whole, and in the whole I can see 3, 6, 9 parts. So what would that be as a fraction? Okay, so that is 3/9 of the whole. But equally, another way to visualise it is I can see that the football zone takes up 1 equal part out of the 3 parts. Because you could look at it like this: 1, 2, 3. So I wrote them both down because they are equivalent. So I could say that the football zone takes up 3/9 or 1/3. And then the quiet zone takes up 1/9 of the whole playground. Do you agree with me? Share your work with me afterwards on Teams. So the next question is, what fraction of the playground do both of the zones take up altogether? So if you were to add the zones together, what would the answer be? So I've just put on some working. So quiet zone is 1/9. Football zone, you could say 3/9 or 1/3. So can you work out the answer using that information? Right, let's move on. So Ella's written down her calculation. So she said that she's going to do 3/9 add 1/9. And Will's written down he's going to do 1/3 add 1/9. Who do you think's correct and why? Okay, so in my opinion, they're actually both correct because, as we discussed before, 3/9 and 1/3 are equivalent. But I like Ella's workings better because it makes it easier to get to the answer. And we'll find out later why. Okay, but they're both correct. So this is another way to visualise that 3/9 is equivalent to 1/3. Right, and you can see that 3/9 add 1/9 is 4/9. So the rule to remember when you add fractions together is that you only add the numerators. You don't add the denominators together. And we're going to learn some more about that now, and we're going to focus on it tomorrow as well. Right, so look at this picture now. This is a common question that we see a lot in tests. What fraction of the whole is shaded blue? Okay. What fraction of the whole is shaded red? And the final question is, what fraction of the whole is shaded all together? So you'll need to add the red and the blue part together. Now the clue is that you can only write down a fraction if all of the parts are equal. So you may need to use your finger on your screen, so you may need to point to it and draw some imaginary lines. Okay, because if you remember earlier on, we had to draw some imaginary lines to visualise all of the parts being the same size. So see if you can have a go. Start with the red shape. I always think about how many of these red shapes could fit into the whole, and that will then tell you how many equal parts there'll be. That'll tell you the denominator. Same for this little blue square. Work out how many of this size will fit into the whole. Okay, visualize and also point and count. Have a go. Right, I'm going to reveal some workings that I've done, so press pause if you're still thinking. So what I did was, I was lucky because I've got the picture on my screen, so I've drawn on it to show you. So first of all, I started to think about the red square, and I thought that actually if you can see my lines, 4 of those squares fit into the whole. So I think that 1/4 of the whole is shaded red. Okay? But I also thought, well, actually, you could think about it like this. So you could have 1, 2, 3, 4, 5, 6, 7, 8. You could say that the denominator is 8 and that 2 parts are shaded. So actually, you could say that 1/4 is shaded red, or 2/8 is shaded red, or down here, 4/16 is shaded red. As long as all of the parts are equal, then it's fine. And then at the end, I just checked. Are the 3 fractions equivalent? Do they mean the same thing? That will help me to know if I'm right. And I can see they are right, because my loops show that I've done the same to both the numerator and the denominator. So did you get at least one of these fractions as your answer? Now moving on to the little blue square. So I think this picture is the most helpful for the blue square, because you can see that all of the parts are the same size as the blue shape. So how many parts are there in the whole? 1, 2, 3, 4. 4, 8, 12. There are 16 equal parts in the whole, and only one of them shaded blue. So did you get the answer 1/16 for your answer for the blue shape? So there's the 2 questions that have been completed. We need to do the third one now. So what fraction of the whole is shaded all together? So on screen, I have placed the red information that we had earlier on the screen. Which of these fractions will be best to use? Because we've got to add one of these fractions to 1/16. Which one's most helpful? Should we do 1/16 add 1/4? Should we do 1/16 add 4/16? Or should we do 1/16 add 2/8? What should we do? Okay, obviously these 3 fractions mean the same thing, but I'm hoping that you chose 4/16, because as I said earlier, we can only add the numerators together. So the rule is that when you add and subtract fractions, the denominator must be the same before you start the calculation. So that's why we find equivalent fractions. Okay, so that's what we're going to focus on for a couple of days. So here's another way to visualise that we have 1/4 add 1/16, so the answer for the total shaded is 5/16. It's good to visualise in different ways. Now, final part of the lesson involves us looking at fractions that are related. Okay, because if you remember earlier on, the boy said that he was going to do 1/3 add 3/9. Okay, so before he worked out the answer, he'd need to make both the denominators the same. And we can say that 1/3 and 1/9 are related because a common denominator can be found. So I'm going to explain that now. So related fractions have denominators where one denominator is a multiple of the other. So the correct sentence in this part is 1/9 and 3/9. Hang on, let me go back. So here we can see that we can change 1/3 into ninths, and then they both have the same denominator. We don't have to change both fractions. I'm not making much sense now, so let me move on. It'll make sense in a moment. So here's a good way to understand it. A way for me to say this question is I could say 3 cats add 2 cats equals 5 cats. Simple. Okay, this will make sense in a minute. What would you say for this question? 3 cats add 2 dogs equals... Ooh, hang on. What would you say at the answer? I mean, the one before was easy. 3 cats add 2 cats equals 5 cats. What would you say here? 3 cats add 2 dogs equals 5 cat dogs? No. The cat dogs wouldn't become cat dogs. What would you say? Okay, I thought you might say 3 pets add 2 pets equals 5 pets. Or you might say 3 animals add 2 animals equals 5 animals. Notice how we've had to find a common denominator to be able to answer this question, because we couldn't say cat dogs. They don't exist, do they? So that helps us with our fractions. So the final activity for today is to look at related and non-related fractions. So what I mean is when you look at a calculation, you need to make the denominators the same to be able to work out the answer. So the stem sentence is, if I choose one as an example, 1/6 add 1/18 are related fractions because the denominator 6 is a multiple, the denominator 18 is a multiple of the other denominator 6. So what I mean by that is, hang on, let me just show you. Just going to get it up on screen. Oops, it's frozen. Okay, so let me just show you. I'm just popping it on screen now. Oh, it's just frozen, hang on. Still frozen. Any minute now. Right. So, here we go. Hopefully you can see that now. So 1/6 is equal to 3/18. So I can now do that calculation. So the answer to that calculation would be 3/18 add 1/18 equals 4/18. Because remember I said you only add the numerators together. So you need to work out of these questions which ones do you only have to change one of the fractions. Okay, if we look at 1/9 add 1/4, well, I can't multiply 4 by anything to get to 9, and I can't multiply 9 by anything to get 4. So 1/9 add 1/4 would go in the non-related fraction box, because I'd have to change both of those. So I wonder if you understand what I mean. I'd like you to pause the video and have a go at this, but if you're not sure, I'm going to go through one more question that might help you. So I'll go through 1/25 add 1/5. So you ask yourself, can I multiply 25 by anything to get to 5? No. Can I divide it by anything to get to 5? Yes, I can, but I can't divide the numerator, so I'm going to leave 1/25 as it is. Can I multiply 5 to get 25? Oh, yes, I can. So actually these fractions are related. 25 is a multiple of 5. So I can do my workings. So you do your workings. So set up your loop. So 1/5. I'm just writing mine down. I'll show you. 1/5. Okay, so I'm just doing it. Remember, whatever you do to the numerator, you do to the denominator. Okay, I'm going to pop my workings on screen, see if you agree with me. Right, 1/5 equals 5/25. I multiplied the denominator by 5, so I did the same to the numerator. So the answer to that question would be 6/25. So as you're going through the questions and sorting them out, maybe you could write the answers down as well. But the fractions are related if you only have to change one of them to find an equivalent fraction. So sometimes the denominators are multiples of one another. So 12 is a multiple of 3. Right, you have a go. Okay, I'm going to reveal my final answers. So I've ticked all of the questions which are related. And the 3 questions that have dots by are not related. You would have to change both of those fractions. Here's my workings. So I changed a half into 2/4. So I did 2/4 add 1/4 equals 3/4. So 4 is a multiple of 2. Down here I did 3/18 add 1/18 equals 4/18. So 18 is a multiple of 6. Over here I did 1/3 equals 4/12. So 4/12 add 1/12 equals 5/12. Over here the answer would be 6/25. Down here the answer would be 3/10, okay, because 10 is a multiple of 5. And there's an example of my working, so hopefully you did your workings like this as well on your piece of paper. We're going to look in more detail at the other 3 questions tomorrow. You may already be able to solve those problems because we have done something like that before in school, but we're going to revise that on Friday. But here's a little bit of information first. So this is how I find a common denominator for 3 and 8. So for 1/3 and 1/8, I've written down my 3 times table, so multiples of 3, and I've written down multiples of 8. So then I'm going to look at both my lists and see if any of the numbers appear in both sequences. So I can see 24 is a multiple of 3 and 24 is a multiple of 8. So for this question, I'm going to turn them both into 24ths. Now, I'm not going to do that now because I know I've rambled on quite a lot today, but we'll do some more of that tomorrow. So hopefully you've enjoyed the session. Please share your work with me, and sorry for rambling on for so long.